Hello, and welcome to Chapter 3. Before we start talking about if statements, I want to step back and talk about Boolean logic or Boolean algebra. This is the basis for conditional statements used in if statements and in while statements. But first, this lesson assumes that you already have viewed the videos on variables and assignments. So let's get started. First off, I did a Google search on Boolean algebra tutorial. I found a nice one here at www.learn-c.com, boolean.htm/boolean.htm. If I click on that, I get what looks like a bunch of tables here. Okay. In C++, we will only be concerned with ands, ors, and nots. To an extent, we will talk about XOR, but we probably will not use that. So for any Boolean statement or any conditional, a conditional will resolve to true or false. Those are the only two possibilities, is true or false. So if the sky is blue, I'm happy. If the sky happens to be smoggy, then I'm not happy, right? Because it is not blue. So if you consider an AND statement, if this and this, the result is what we have here. So what we are saying is if input 1 is 0 or false, and input 2 is 0 or false, the conditional statement is false. If the input of input 1 is false and input 2 is true, we still have false. If input 1 is true and input 2 is false, we still have false. The only time an AND statement is true is if input 1 is true and input 2 is true. For OR, it's a little different. For an OR to be true, either the left side or the right side must be true. As we can see, in this row, input 2 is true. Therefore, the output is true. In this case, input 1 is true, so the output is also true. In this case, input 1 is true and input 2 is true, and we are still true. XOR is a little different. XOR says if one side and not the other side is true. So one of the two items, but not both. So if input 1 is false and input 2 is false, the output is false. If input 1 is false and input 2 is false, the output is true because only one side is true. If input 1 is true and input 2 is false, our output is 1. And finally, if input 1 is true and input 2 is true, the output is false because only one side is true at a time. We will probably not be using XOR, but I just wanted to discuss it. Not is simply saying if the input is true, the result is false. If the input is false, the result is true. So let's talk some real world examples now. So I have a flower garden, and the flower garden has roses, mums, lilacs, marigolds, and petunias. Okay? The colors of the flowers in my garden are red, white, yellow, orange, and purple. Now we can come up with some conditions. What is a condition? A condition will evaluate a statement. A condition can be true or false only. There is no maybe. One condition we have is if the flower is a rose, then I am happy. So the condition is flower is a rose. And I will abbreviate things in this discussion as such. If flower equals rose, then I'm happy. On the flip side, we can say if flower is not equal to rose, then you are happy. So basically, if you're looking at any other flower in my garden besides a rose, you're happy. While I am only happy when I see roses. We could take this a step further. If the flower is a rose and I will signify this by 2 ampersands, and the color equals red, then Mary is romantic. So what we're saying is, if Mary sees a flower that is a rose and it's red, she is romantic. If the flower is a rose and happens to be yellow, she is not romantic because the condition must evaluate true or false only. And when we have things with an and between them, both sides have to be true. If one side is false, the whole condition is false. Therefore, if flower equals rose, that's true. But the color is yellow? Well, if we're looking at a red rose, then it is not true. And Mary won't be romantic. We could also make a statement like, if flower equals rose or flower equals lilac, then I am happy. So in this case, I'm happy whenever I see a rose or lilac, regardless of the color. Okay, another way that I can see things is if the flower is not a marigold, and the flower and the color is not white, then I am happy. Okay, so this is saying if there is any flower except the marigold in my garden, so I can potentially be happy when I see a rose, a mum, a lilac, or a petunia, but only if the color is not white. So once again, this side has to be true and this side has to be true for two Booleans to be true. For the whole statement to be true, both sides have to be true. Now I can make my conditional a little more complex. I can make a statement like if color equals yellow or color equals red, and let's and this with flower equals rose. Let's keep this all on one line. So if I'm looking at a rose, only a rose, and the color happens to be red or yellow, then I am somber. So in this case, we have an AND statement. For an AND to be true, we need this side to be true and this side to be true. This side, the side on the left, is everything between the parenthetical statement. So, if the color is yellow or the color is red, if either of these conditions is true, this side is true. If the flower is rose, then this side is true. We AND those together. If this side is true and this side is true, I am somber. This statement is not the same as if color equals yellow or color equals red and flower equals rose. We have an order of precedence here. I forgot my double equals here. Gotta be consistent. Consistency counts. Except I want this all in one line, so I'm just going to do this. So if I'm looking at a flower and the color is yellow, or the color is red, and the flower is rose, we have operator precedence. And comes before or. So what I'm really saying is if the flower is a rose and it's red, or I'm looking at something that is yellow. So if I'm looking at a flower that's yellow or I'm looking at a red rose, I am ecstatic. So we will get into some conditions and some if then else cases when we talk about C++. But hopefully this brief introduction of Boolean logic can get you started on how to think about conditionals. This concludes this video.